Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on power transmission through nozzle. In our last few lectures, we are discussing regarding the power transmission through nozzle, flow through the nozzle, and what is the condition of maximum power transmission. So everything we have discussed. Now, based on that concept, let's solve a problem now. So the question I have taken here. Find the maximum power transmitted by a jet of water discharging freely out of a nozzle fitted to a pipe that is 300-meter long and 100-millimeter diameter with coefficient friction as 0.01. The available head at the nozzle is 90 meter. So what we need to calculate? We need to calculate the maximum power transmitted. What is the maximum power transmitted? The question is very, very simple. Just we need to understand. So here, if you see, suppose we don't know about the topic, and like means you are not able to remember the topic. Somehow you forget that one, but we know the concept. If you know the concept, you can easily solve it. See, in this question, it is asking that find the maximum power transmitted. So we need to calculate the power. But thing is that we need to remember the formula. Without formula, we cannot solve it. By a jet of water discharging freely out nozzle fitted to the pipe. So here, if you see 300-meter long, that means the length of the pipe is given 300 meter and diameter of the pipe is given 100 millimeter, and with coefficient of friction is given 0.01, and the available head at the nozzle is given 90 millimeter. So by this data, we can able to calculate the maximum power transmitted. Anyway, so the formula for this actually, though I have written this one, let me write the formula also here itself. So this is rho g QH by 1000. Actually, this is the formula for power transmitted, maximum power transmitted. Anyway, so now let me write down the data given actually for this question. So the data given in this question is first one, the length of the pipe is given L equal to 300 millimeter. So length of the pipe is 300 millimeter and diameter of the pipe equal to 100 millimeter. So from the diameter of the pipe, we can easily identify the area, and friction, coefficient of friction is given 0.01, and the head available at the nozzle H. This is the head available at the nozzle part actually. So that is H equal to, you can write this 90 meter. Okay. Now, yeah. So what is the maximum power transmitted through the nozzle? The diameter of the outlet will be, we know that there is a formula is there. In the last lecture, we have derived that one. So actually we know that D equal to d to the power 5 8 FL whole to the power 1 by 4. This is actually the diameter of nozzle. Okay, the diameter of nozzle through which the water, the fluid is supposed to come out. Okay, so this is the formula actually which we have derived in our last lecture. Anyway, so from this we can find out the diameter of the nozzle. So this is the head available at the nozzle and this is diameter. So first let's find out the diameter. Now here actually this is also okay. No, this one you take it capital D, otherwise you'll be confused. This is diameter of the pipe capital D and this is diameter of the nozzle, that is small d. So now we will put the value here. So this one we can convert into meter because everything are there, every terminology are in meter only. Let's convert this one. So now this is 0.1 to the power 5 divided by 8 into F. F equal to 0.01 into L, length is 300. This whole total to the power 1 by 4. So here we'll get the value of the diameter of the nozzle. Anyway, let's calculate this. 0.1 to the power 5, 0.0000. Anyway, so this is 0.00001. Okay. Next, divided by, okay, why I deleted, 0.1 to the power 5 equal to this, and divided by, let bracket start, 8 into 0.01 into 300, bracket close. Now this will be give you the value of this. Now whole to the power, bracket start again, 1 divided by 4, bracket close, 0.0254. Yeah, so finally you will get 0.0254. okay, so this is the meter, and here we'll get this whole total, get something, and let's write this 0.01 into 300. So finally we'll get the value of diameter is this much. Now, so area of the nozzle we can calculate. Area of the nozzle, small a, equal to pi by 4 into d square. So again we can calculate this, this much square, okay, square of this into pi divided by 4, 5.06 into 10 to the power minus 4. So we can write 0.00. So here we can write this is 0.0005. Next value what? 069. This much meter square. This is the area of the nozzle. Okay. Now nozzle, actually the nozzle at the outlet of the discharge, which is coming out to the atmosphere. So we can write the total head which is available, at the nozzle, that means head at the outlet condition, which is converted, totally converted into kinetic energy. So H at the outlet condition we can write, this is kinetic energy, nothing but we can write V square by 2G. This one already we discussed in our theory part, how it came, like means the total energy which is present at the fluid will be converted to kinetic energy at the nozzle part. So the head at the outlet equal to, we can write the kinetic head, so that is V square by 2G. Now H outlet, we know that is 90, already given, and here V square by 2G. So from here we can find out the value of V. Value of V equal to 90 into 2 into G, and this is whole root. So what we'll do, let's see how much is coming. So 90 into 2 into 9.81, this much root over 42.02. So now we got the value of velocity 42.02 meter per second. Now we got the velocity. Okay, now this is velocity we got. Now again let one more term, we know that this is velocity. Now discharge we required, because in this formula if you see discharge required, so discharge equal to A into V. So area already we found here, this is the area. So 0.005 069 into the velocity value 42.02 something is there. So if you calculate this, now this one multiply of 0.0005 069. So discharge equal to 0.0213, this much meter cube per second. This is the discharge value. Now what is our intention? Our intention is to calculate the maximum power transmitted, that is P equal to, we can write here, rho value how much? 1000, rho density of the fluid, that is water, 1000, G equal to 9.81, and Q just now we calculated 0.0213, and what is the value of H here? H already given, the outlet head divided by 1000. So 1000 can be cancelled, and let's see how much we are getting. 0.013 into 90, into 9.81, 18.8, 18.8 kilowatt. This much power will be transmitted. This much power will be transmitted. This is our final answer. I hope you understand this problem, how to solve it. This very simple, but we need to remember some formulas like what I told you, that power formula and the diameter formula, which is basically required. This formula we have derived in our previous video lecture. So, and these other things, common things are there. You can use it. I hope you understand. If you are having a doubt regarding this, you can give comment in the comment box. Thank you all.